good morning everyone. Welcome to our today's webinar. Are you prepared for the next zero-day attack? I'm Smita More, Marketing Manager here at Accelerite and your host for today's webinar. Before we begin today's session, I have a few housekeeping announcements to make. This webinar is approximately 40 minutes. Friends, also note that our session is being recorded and we'll make the link available with everyone after the session. We have kept everyone on mute to ensure that any background noise and conversations are kept private. To ask the questions, please make use of the question box on your GoToWebinar window. Feel free to write your comments, questions, and anything that you want us to see in this question box. After the presentation, we'll try to attend all your questions. That's all about the housekeeping. To begin with, just a quick note about who we are. Accelerite is a wholly owned business unit of Persistent Systems. Persistent Systems is a leader in software product development and technology services. Accelerite is a software provider that was set out to simplify and secure the enterprise infrastructure. Today's enterprise infrastructure spans across mobile devices, PCs, tablets, servers, clouds, and increasingly connected devices. We at Accelerite create the most flexible and customizable software to manage and secure this complex infrastructure for every enterprise. As you all can see on the slide, Accelerite has these software suite of cloud, IoT solutions, advanced endpoint management, and analytics. Accelerite is located in Santa Clara with over 300 employees located in 6 different offices globally. More than 3,000 customers from Fortune 500, SMEs, operators, service providers around the world rely on Accelerite products to secure connected enterprises from a single pane view, quickly and easily build private and public enterprise clouds, and bring connected things to life with rapid IoT service creation and enrichment. Do visit our website www.accelerite.com to know more about our products. We'll now get started with our session. Let me introduce you all to our today's speaker, Shivesh Vishwanathan. Shivesh heads the strategic product marketing team for the endpoint business at Accelerite and is the subject matter expert in the endpoint management and security technologies. Shivesh has about 19 years of experience in the client-side technologies and mobility platforms and has held multiple roles as software developer, product manager, and most recently as product marketing head at Accelerite. He is the computer science graduate and holds an MBA from Duke University's Suka School of Business. Shivesh, welcome to our webinar. With this, I'm handing over the session to you.
Hey, thank you, Smita, and hello everyone. My name is Shivesh Vishwanathan, and I'm part of the product group of Accelerite's endpoints business. It is a pleasure to be here today. So corporate IT teams, as you know, they manage thousands of endpoint devices, and these devices, include PCs, laptops, ATMs, kiosks, POS devices, and many more as part of their endpoint management and operations. So over the next 20 to 25 minutes, I will be talking about what it takes to be prepared for threats and attacks that exploit zero-day vulnerabilities on corporate endpoints and applications. I will show how IT teams today can use real-time queries on these endpoints to further develop their understanding of their endpoints, pinpoint vulnerabilities in them, critical configuration attributes, and so on. And the IT teams can really enhance their ability to diagnose issues and fix problems with endpoints in near real time with these capabilities that I'm going to showcase today. So, but before we get into the details about zero-day, let's just take a quick look and look at what zero-day attacks are for those who might not be familiar with it. And let's also look at the nature and magnitude of the problem. So zero-day vulnerabilities are vulnerabilities in software that are unknown to the vendor and which hackers could potentially exploit. So here's a quick chart that I wanted to show. It shows the chronology of events around zero-day vulnerability and attacks. The sequence of events here could vary a little bit, but this is an illustrative flow of what happens and what causes zero-day attacks and zero-day vulnerabilities. So a vulnerability gets introduced on the left. It gets introduced into a software, say with the release of a software version. But important thing here is that no one really knows about it. Not the developers who coded the software, not the testers who tested it, and not the customers who might have also done their own basic testing before deploying it. So it kind of escapes everybody's view here. So the vulnerability lies dormant for some amount of time until the point that someone discovers and unearths it from the wild, which is the second bullet in this diagram, the second stage, right? Now that person or group of people who unearth it could be a group of ethical hackers. It could be a customer who bumped into the problem while using the software. It could be malicious hackers who are constantly looking out for opportunities to make money by exploiting the vulnerability themselves, maybe selling that information to someone else and making money, or even at times holding a user or customer of that software to ransom in order to extort money. So quite literally, this is the case. This is exactly the case when someone says, "I need this fixed yesterday." So that's exactly what is happening here, right? And hence the name is zero-day or day zero vulnerability. The hackers could, exploit the vulnerability until a patch is deployed on target systems, and the vendor of the software has a very small window available to fix the problem and release a patch or a fix and so on. Once the vulnerability is identified and comes into the vendor's knowledge, the vendor could proceed to fix it, and at some point, the vulnerability gets released into the public domain. And then after that, the patch is deployed and the problem is eventually fixed. Now, depending on the sequence of these events, like I said, it could happen that no one comes to know or actually tries to exploit the vulnerability, and you are able to deploy the fix well in time. That is one scenario. The other extreme scenario is that you could realize that someone had actually already unearthed the vulnerability long before and has been exploiting it for some time. So somewhere in between these two extremes that I just said, the attackers get a finite window of time when they could attack you. Once the vulnerability is known to you and the public, what you have on your hand essentially is a race towards handling and mitigating the problem at least, at least temporarily, until the vendor is able to provide a permanent fix. So potentially, a malicious hacker could still be in the race to exploit the software. So that's one person. The vendor, of course, is trying to get a fix in as soon as possible. Get the fix in, test the software, release the patch, all of that before it gets too late. And you as a user would be trying to minimize the impact as much as possible, right? So it's essentially a race against time. Now, but here's an interesting thing about destination that you want to reach, right? All the three people are trying to reach to fix the problem before anyone else gets to it. But the thing is that if you take a map as an example, it turns out that maps are generally pretty futile for getting directions to a point unless you are first able to spot yourself on them. So let's say you want to get to a point, unless you have a good knowledge of where you are on the map yourself, getting a direction is basically impossible. So I would like to paraphrase Watts Humphrey here, and Watts Humphrey, as some of you might know, he was a key thinker of software process and engineering, and he was a winner of the National Medal of Technology given by the President of the United States. What Watts once very famously said, and he actually said it in the context of implementing software processes, but what he said was that you have to be able to first take stock of where you are adequately before you can get to any place else or any place that you want to go, right? So translating that to our context here, as soon as you are made aware of a zero-day vulnerability in your system, either only you know it or the entire public knows it, including hackers, the first order of business for you is to be able to adequately identify, pinpoint, isolate, find a workaround, essentially temporarily try to fix the problem so it doesn't spread. And this is an interesting data point that I wanted to share. This is from an HP Enterprises cyber risk report earlier this year. It called out the fact that attackers are increasingly attacking applications, and they have shifted focus away from servers and operating systems to applications and endpoints. The reason is quite simple, really, if you think about it. There are hordes of applications that run on corporate endpoints today, right? There are laptops, and laptops, interestingly, today comprise of over 60% of the computers out there, and only the rest 40% are traditional PCs that are not portable. And this is only increasing. So it's 60 today, and it's only increasing in the favor of laptops as we go forward. And what happens is that these laptops, because they're portable, are also they work outside the corporate network. They're out on the public Wi-Fi networks. They are in airports, coffee shops. They use hotspots which might not be very well secured, and so on. So they're essentially they might be out of your network and out of your control to that much degree. So if you take a step back and look at how traditional endpoints have worked within an enterprise, the PCs and laptops to a large extent have had a relatively safe existence. They work within corporate physical boundaries, even network boundaries. They are usually secured and managed by actually a host of tools. There are so many tools, right? There are VPNs, firewalls, endpoint protection platforms, endpoint management solutions, DLP tools, antivirus, and so many more. And that absolutely does need to continue. However, the problem is that these endpoints are now more vulnerable with applications running on them and corporate data stored on them. And like I said, they are operating from outside the outside the corporate network. So the diagram on the right side kind of illustrates that problem. Right. So let me take an example to make this a little more understandable, and you could actually see some things in action here, right? So we can understand the zero-day vulnerability that could potentially result in an attack, or maybe the attack is already in progress without anyone's knowledge. So let's say you actively manage about 20, 25, 30,000 PCs in your enterprise, and you get a call from your vendor or anyone else that there is a vulnerability in one of your software that the vendor has been informed about, or that person has been informed about. It might be public, might not be public, and all of that. Now, you are advised to take a certain set of steps to protect your network and endpoints. It could be a workaround that you need to apply. It could be like just disabling or uninstalling the software temporarily. It could be even maybe changing a registry entry. It could be just terminating the process. Essentially something that requires you to take stock of the vulnerable endpoints at a particular point in time and take remedial actions until a more permanent fix is available in the form of a patch. So now the manifestation of programs on PCs and endpoint is ultimately probably just a file that is there or a set of files. It could be a process, it could be a piece of software that is running on corporate PCs and laptops, or maybe even an existence of registry entry, or something which is actually pretty simple to understand, right? The remediation action, a temporary one at least, in order to avoid problems would be to maybe uninstall that software, terminate that process, maybe delete that file, or get the machine that is running that software out of the network temporarily, etc. So you could take any of these actions. So as you can imagine, what would be considered a simple piece of information would actually turn out to be a huge project for IT, right? This is not something that you can pull off very easily. In this case, let's say the file or process is named SQL data collector.exe. It's just an example of the file name, right? That's the name of the file that that is vulnerable, that has been found to have vulnerability. And you have to find all occurrences of a process by this name on each and every PC. Now, what you'd have to do is you have to comb through your entire network of endpoints to find that needle in the haystack, that one file, this one process. Now this might be a piece of software, version of software, etc. I mean, all this, it could essentially cause a huge embarrassment and financial impact for your company, say, right? So, currently it might take your team actually days or weeks of, manual effort to gather all the information from all the corporate PCs and laptops, and they need to bring them together in one place in order to plan the next course of action, which would be to remediate them or apply some kind of a temporary stopgap fix. The process would involve, usually it will have you'll have to use multiple tools. Maybe there's some remoting software that might be needed to check in on PCs. Maybe some manual checks also distributed globally, and mostly, essentially, many person hours of meticulous work is what it would take today, right? And interestingly enough, like the points, what Humphrey was making, what we saw, it is, unless you know where you are, it's very hard to get to your destination. There's no map that's going to help you, right? So it is usually similarly, it is usually much easier to remediate and fix a problem once you know where you stand, right? So and you remember, you need to be able to do this quickly enough and easily enough. So you need to first find yourself on the map. You need to be able to find the current status of endpoints first before going ahead and solving that problem. That's essentially a very important aspect. So now the problem is that, if you go back to the diagram of the way traditional endpoints have been managed, and they're still being managed, is that the endpoints are looked at only as part of the problem, and they are not really made part of any solution, really, right? You apply fixed patches on them, you fix things, you change configurations and all of that, but they are not really made part of the solution. They are managed in this one-way flow model where they are merely at the receiving end of patches, updates, configurations, software, and so on. But guess what? The endpoints could be much more than that. They can be part of the solution. We can close the loop on this flow and win this battle of wits, between attackers and IT. Today's actions to fix problems and responding to incidents are largely isolated actions performed by various teams, right? Treating endpoints themselves as a source of information could provide an unprecedented amount of context on which IT can act. You can gather a lot of contextual information before you perform any action, or do it after, to verify the results. So you could do it before performing an action, gather contextual information, then act, or you could act and then gather information to verify the results of your action, right? But in both the cases, you can basically quickly take stock of the latest situation. That's kind of the key message here. And that makes endpoints part of the solution. However, closing the loop for endpoints diagnostics, is easier said than done. For one, endpoints are not simple systems of record like databases, standard SQL queries that you can run. So if you see on the top, the information source box on the top there, the other three software vendors, PatchDB, vulnerability database, all of these are just standard databases whom you can query and get information very quickly. Endpoints are different. For the querying and responses from endpoints to be in real time, there is a processing of large amount of information that is involved. You need to get individual and specific details from each of the endpoint. You need to be able to categorize them quickly. And finally, you need to be able to provide the ability to remediate them in place. So all of that should happen in real time, just as if you are querying a database. And that's not an easy problem to fix. So with that context, let's go back to our example that we started with, which is you need to find the file called SQL data collector. Let's actually look for a process instead of file. So across all endpoints, you need to find if this process is running and which PCs this process is running on. As an illustration, if you look at Sentient, Sentient is Accelerite's endpoint detection, response, and diagnostics tool. Querying for endpoints is as simple, and here we can with natural language processing. So let's just jump right in. So there's a simple search bar in which you can type in near natural language query. That is a powerful way to glean very specific information from endpoints. So you can see I'm looking for a process here. There's some assistance available in terms of a drop down. It could be a file name, a registry entry, existence of antivirus agent, and just some processes or some queries that you get out of the box. I'll show a more comprehensive list of what all you can do in just a few minutes. But essentially, the point here is that the freeform text queries is the first key aspect of sentient EDR, and the ease with which you can query and get the responses. So now that we have typed the query, let's run it and see the results as they start pouring in. So as you can see here on the bottom left, the results have started coming in. So there is 36,000. You blink and you will miss it. So there are a lot of results that are coming in instantly. So 72,011 seconds, 90,000 PCs scanned in 14 seconds. We have 108,000. Yeah, so I think this is about it. So in about 20 seconds, we have scanned little over 110,000 machines out there in your network. And we have brought all that information in. Now, the aspect that I wanted to cover here, the three key aspects that I wanted to cover here, we covered the first one, which is natural language query. The second aspect is real-time at huge scale that you can see at the bottom left. So all this information, remember, is coming live from endpoints at this instance, right? The third one is on the top right is a visualization of results. So you have this different types of graphs and charts that you can see. You can visualize and slice and dice the information in multiple ways, and you can understand the data better. You can hover over these graphs so you can in order to drill down to further details. And the fourth aspect on the top left that you see is big data processing. This is a very interesting one, which is that all these endpoints are returning data at a very high velocity and in huge numbers, right? The processing itself includes a lot of slicing and dicing the information to create results that are easy to understand. For example, here you see the data that has come back has been categorized 4 different ways. There are 4 white boxes that you see, right? So on top left you have by device type, by OS type on top right, bottom right you have by OS version, and on the bottom left behind the bubble is actually by subnet, right? So all this processing is happening in real time. Graphs are being generated in real time, lists are being created for you to act on, and so on. So let's move on. So once you have the results, you can drill down to see the detailed endpoint data. So there you go. Yeah, so there you go. You get a list of specific endpoints that have this process running. So if you scroll down, we see each PC that has this process running at that instant when we ran the query. So that's the fifth aspect that I wanted to cover, which is you get a specific list of PCs along with a lot of details, MAC address, operating system, and all of that from each of those PCs. And the second is that there's a remediate button there, as you can see. In this case, if you click on that button, the remediation operation for finding a process is actually, you might want to terminate the process. You can select each PC and you can terminate the process. Of course, this remediation action will change with each different queries. If you're finding a file, it could be delete a file, or upload a file if it doesn't exist. It could be applying a patch if the patch is not applied on an endpoint, and so on. So the remediation action will itself vary. So the important point is, in place you can remediate from the same console. So quickly summarizing, so these are we saw 6 aspects for endpoint detection response capabilities of Sentient, right? We saw the free-form text queries, that was the first one. Visualization of results for you to be able to slice and dice quickly and look at multiple different types of graphs and charts. Big data processing is the next one, which is for you to be able to process data which is coming at high velocity and in huge numbers, and real time at huge scale, which is an important aspect for number of PCs. You can see the list of endpoints and locate specific endpoints that you want to get to, and finally, you have the capability to in-place remediation on these endpoints. So these are the 6 kind of salient attributes for something like this. So the endpoint characteristics that Sentient can glean from the endpoints, and we saw, as I said, we'll come to this point on what exactly you can get through those queries. It includes items that are seen here. So there's hard disk information, CPU information, memory, software, patch, file. There's a whole host of attributes that you can query, and we'll see these kind of fall under 5 major categories, and we'll come to that in just a second. But this is the information that you can get from an endpoint through a query. Get from rather all your endpoints through a single query that you can fire and get results in real time. And the other aspect that I wanted to touch upon is that there are various use cases that an EDR solution like Sentient can support. So on the left, you can see here, these are the endpoint characteristics. So what we saw in the previous slide, there are 5 categories of information. So there's files and processes, there's settings and configurations, software attributes, device attributes, user attributes like authentication, access, admin rights, and those kinds of things. Now, once Sentient gets all these information from the endpoints, from so many endpoints, and then it processes it, shows it to you in different various forms. On the right, you see that this information still can be applied on multiple functions within IT, right? So on the right, you can see the various sub-functions, things like you can use it to improve your incident response, advanced endpoint management, you can do information protection, security, and others. So all these use cases and processes can be enhanced, right? Now it is worth pointing out here that it is not that Sentient will replace any of these tools or solutions and platforms. Sentient rather acts as a catalyst that enhances these IT operations, and it acts as a gateway security solution that provides additional context for IT teams and managers to act on. So for example, your security and vulnerability management can be made more robust and reliable, like we saw in the demo just now. It can be made more robust and much faster. Your endpoint management actions can be much better informed rather than just flying in the blind kind of thing. Your audit and compliance process can be speeded up tremendously using something using Sentient, because you're getting real-time information on the current state at any point of time. So there are multiple such functions and processes and use cases that will benefit from Sentient. And so the impact of this catalyst behavior is tremendous, right? So IT leaders who we have talked to, who have tried it firsthand, say that they felt like they were essentially flying blind earlier in the absence of Sentient. Now their work is much more well-informed. They know exactly when they are supposed to act, what impact their actions will have on their environment, and so on. So tremendously useful. So I wanted to conclude this part of the presentation. So what I wanted to conclude with is that this a data point, it's an interesting data point here. So these are statistics of the scope of zero-day vulnerabilities in 2016. So you can see big vendors with widely used software are essentially the soft targets. And obviously these are software that is pretty much used world over by each and every company, right? So for example, talking about big vendors, zero-day attacks hit Microsoft software right after the company delivers its patches on Tuesday of every month. And interesting, we in our space, we like to colloquially call it zero-day Wednesday. So zero-day vulnerabilities are fixed by vendors eventually, but they also do open up a window of opportunity for attackers to attack software, especially the popular software. Having the ability to quickly pinpoint and locate the affected endpoints and to be able to quickly act on them will be a crucial tool in your hands to manage such vulnerabilities. So the essential takeaway is that don't let these blindside you. The solution, the key takeaway again here is that the solution lies within your endpoints, and you should be able to utilize that fact. Today the endpoints are part of the problem because they are getting managed by tools and solutions. What Sentient can enable you to do is bring endpoints into the fold of the solution of the problem domain, and you'll be able to get real-time information from endpoints in order to act better on them. So with that, I would like to hand it over to Smita, and I would love to answer any questions at this time. Smita?
Yeah, sure. Thank you, Suresh. This definitely was a very insightful session that we had today, and definitely all the data points that you have shared are definitely of much use. Friends, with this, we are opening the session for question and answer. We'll try to attend as many questions as possible in this session today. I can see there are a couple of questions that are coming in. We'll give few more. We'll give some time for a few more questions to come in. Till then, here's an interesting announcement we had. We are offering 30 days free trial for our product Sentient to first 20 requests. Send in your requests to us at sales@accelerite.com. So please note that this is only for first 20 requests that will come in, and we'll be sharing the 30 days free trial of our product. So please drop an email to us after this webinar is over. Shivesh, I'll just read out a couple of questions that have come in, and there are many more that are still coming in. I can see that are coming in. The first question is, does Sentient support access control for administrators?
Right. Yeah, that's a good question. So, yeah, so Sentient supports multiple levels of access control. So there are people who can, just query, and importantly, most IT departments would want to control the process of remediation once a problem has been found. So, so there are multiple levels. You can have custom levels. You can create that setup for yourself, and understand that IT teams will have a particular workflow and process to be followed with approvals and all that in order for administrators to remediate a problem, kill a process or delete a file and so on. So Sentient provides role-based access control, RBAC as we call it, for different levels of administrators to act on different parts of the system and perform different operations.
Okay, there's one more question that has come in, is like, are the queries encrypted before they are sent on the wire? And does that introduce any additional lag?
Yeah, that's an interesting question. So, there are multiple security features that have been incorporated in the product itself. So all the communication, for example, between the endpoints and the Sentient server is secured. All the data that passes through the Sentient system as well as to the endpoints and they are all encrypted. And there are multiple such features that basically ensure that the product is secure for sure. The second part of the question, whether it means there's a lag in the system because of that and so on. So we have tested this with over 100,000 machines, and we have tested it with and without these security features, and there's no visible lag that you can see. There's nothing that is statistically significant at least. So there's no the lag is minimal, if anything, due to these security features.
Okay. This another question which I found, like, maybe it's interesting. Can Sentient reach machines that are outside the corporate network? And what about offline machines?
That's a great question. So Sentient today reaches machines that are in the corporate network. In order to understand it better, we'll have to look at the architecture. We have to sort of understand the architecture of Sentient. So there are multiple levels of servers that Sentient supports. So that means that it can reach out to multiple different types of devices and PCs which are inside, outside, and all of that. And importantly, the PCs and devices themselves, they run an agent. So it's an agent-based architecture. So as long as there is an agent running on the PCs, it is fairly straightforward to reach those PCs. Either the connection could be initiated from the server side or it could be initiated from the client side. But yeah, the short answer is that there's definitely support for PCs that are outside of corporate network that can be added, and that particular thing is in the roadmap, but it will be done for sure.
Okay. This question has been asked by a couple of other attendees also. So which operating system platforms does this tool run on?
Okay. Yes, I think that question has actually two parts to it. I mean, what platforms does Sentient itself run on the server side? That is one part of it. So Sentient, the Sentient server today can be installed on Linux machine, and there's of course more detailed spec that will be there. But essentially, it's Linux machines that the Sentient server runs on today. And there's another part of this question, which is on the client side, which platforms are or which operating systems are supported. I would imagine that's also worth talking about, right? So on the client side, the Sentient agents have been written for Linux and Windows. So it supports Linux and Windows operating systems in terms of the endpoints that Sentient supports.
Okay. Shivesh, we'll take one last question for today's session. Do you have an MSP-enabled product, or are you solely focused on the enterprise?
So the MSP-based product, I mean, so it's an on-prem solution. So one thing is that, so we have talked about, there's also a related question that could be asked, is whether it can be hosted on cloud or it's on-premise. So it's an on-prem solution, and today it is for the enterprises that are there. So you can host it for enterprises, and they can use it. But very soon we'll be coming out with something that can be hosted on the server for multiple different customers as well. Yeah, I think that's probably, yeah, that covers the question.
Yeah, definitely. I also think so. So friends, with this we are ending our session today. Thank you for sharing your time with us today. Shivesh, once again, thank you for addressing today's webinar. Thank you, everyone. Thanks.